Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on linear algebra, chapter elementary transformations, lecture number 3, in which I will discuss about echelon form of a matrix and to find the rank of a matrix through this form. Before defining the echelon form of a matrix, I would like to attract you on these examples. Here we see that A be a 4 by 4 size matrix. That means number of rows before 1, 2, 3, 4. Number of columns before 1, 2, 3, 4. Here we see that in fourth row each entry is 0. Here we see that in third row number of zeros be 2 before a non-zero entry. Here in the second row, we see that number of zeros be 1 before a non-zero entry. In row number 1, first entry is non-zero element. Here we see that first non-zero entry after 0 be 1. Here also 1. Here no 0, but here 1. Here we see that number of zeros in third row is less than number of zeros in fourth row. Number of zeros in second row be less than number of zeros in third row. This characteristic of a matrix is known as echelon form of a matrix. Here we have matrix B. This matrix is of the form 3 by 4 size, 3 rows and 4 columns. Here all entries of third row are not 0. Here number of zeros be 3 before the non-zero entry. Here number of zeros be 1 before non-zero entry, and in the first row no 0 before non-zero entry. But number of zeros before non-zero entry is less than number of zeros before non-zero entry of third row. This property, that number of zeros of the second row before non-zero entry is less than number of zeros before non-zero entry of third row, shows that the matrix B is also in echelon form. It is not necessary that the last row should contain all entries 0. Only the logic is that the number of zeros of a row before non-zero entry is less than number of zeros before non-zero entry of the next row. This is the main point. Here we see that the non-zero entry after zeros of any row be 1, here 1, here 4, here 11, not 1. So generally in echelon form, the non-zero entry after zeros of any row be 1, generally, not mandatory. Here in C matrix, we see that number of zeros in the third row is greater than number of zeros of fourth row before non-zero entry. So this is not in echelon form. To make it echelon form, we need to use elementary transformation R3 double implication R4 means interchanging third row and fourth row, and it will be of the form 1 0 3 2 0 0 1 4 0 0 0 1 0 0 0 0. This is in echelon form. Here, number of zeros before non-zero entry of third row is less than number of zeros before non-zero entry of the fourth row. Similarly, number of zeros before non-zero entry B2 here 3. So this is number of zeros less. So this is in the form of echelon form. Now we define the echelon form of a matrix. Definition of echelon form of a matrix. A matrix A, capital A, is said to be in echelon form if number 1, every row of A which has all its entries 0 occurs below every row which has a non-zero entry. Number 2, the first non-zero entry of each non-zero row is equal to 1. This restriction is not mandatory. Number 3, the number of zeros before the first non-zero entry of a row is less than the number of such zeros in the next row. Now we clarify these points one by one. Firstly, we should know the definition of zero rows and non-zero rows. Here we see that all the entry of this row be 0. So this is called zero row. In this row, non-zero element 1 and 6. So this is non-zero row. This is non-zero row, this is non-zero row, and this is also non-zero row. Zero row is that row in which all entries are 0. So in the first point, it has been given that every row of matrix A which has all its entries 0, occurs below every row which has non-zero entry. So here this 0 row occur below all non-zero entries. This is the number 1. Number 2, the first non-zero entry of each non-zero row is equal to 1. This is non-zero row, this is non-zero row, this is non-zero row. First non-zero entry here of each non-zero row is equal to 1. Here first non-zero entry, this is 0 entry, this is first non-zero entry, 1, and this is also 1. Here we have no 0 entry before non-zero entry. Here also. But in this matrix, here we see that this is the first non-zero entry. These are 0 entry of this row. Here 4 be the first non-zero entry of the second row. Here 0, then first non-zero entry. Here non-zero entry, first non-zero entry is 1. Here 4 is not equal to 1, 11 not equal to 1, although this matrix is said to be echelon form. So this restriction is not mandatory. Means here it should not be that first non-zero entry should be 1. Here 4, here 11. Number 3, the number of zeros before non-zero entry of a row is less than the number of such zeros in the next row. Here we see that number of zeros be 2 before non-zero entry. Here number of zeros be 4. So number of zeros before non-zero entry of third row be less than number of zeros before non-zero entry of the fourth row. Here in the second row, number of zeros be 1 before non-zero entry. In the third row, number of zeros before non-zero entry be 2. So number of zeros be here less than number of zeros of third row before non-zero entry. So the number of zeros before the first non-zero entry of a row is less than the number of such zeros in the next row. Here the third point is sufficient to define the echelon form of a matrix. Means number of zeros before the first zero entry of a row is less than the number of such zeros in the next row. Here number of zeros before non-zero entry be 3. Here number of zeros before non-zero entry be 1. Here number of zeros before non-zero entry be 3. So here less. And this is in echelon form. And so number of 3 is sufficient to define the echelon form of a matrix. It is to be noted that the number of non-zero rows be equal to the rank of a matrix. So rank of A equal to 3. Here also number of non-zero rows be 3. So rank of B be also 3. If a matrix is in echelon form, then the number of non-zero rows denote the rank of that matrix. Now we solve some problems. Problem is, let A be a 3 by 4 size matrix. Then frame A in echelon form and find the rank of A. Now we solve this solution. Given that A be a 3 by 4 size matrix, firstly we make zeros at these places. So to make 0 in this place, we need to use the elementary transformation R2 in the place of R2 minus 2 R1. So 2 minus 2 into 1 is 0. To make 0 in this place, we need to use the elementary transformation R3 minus 3 R1. So we write the first row same 1, 2, 3, 4. Here 2 minus 2 into 1, 0. Here 3 minus 3 into 1, 0. Here 1 minus 2 into 2, minus 3. Here 4 minus 3 into 2, 6 means minus 2. Here 3 minus 4 into 2, 8 means minus 5. Here 0 minus 3 into 2, minus 6. Here 5 minus 3 into 3 means 9. 5 minus 9 is minus 4. Here minus 10 minus 4 into 3, minus 22. We multiply the row 2 minus 1 into row 2. and row 3 minus 1 into row 3, and we will get 1 2 3 4 0 3 2 5 0 6 4 22. Now we make here 0. So R3 in place of R3 minus 2 into R2. Here first row remains same 1 2 3 4. Second row remains same 0 3 2 5. Here 0 minus 2 into 0 0. Here 6 minus 2 into 3 0. Here 4 minus 2 into 2 0. Here 22 minus 5 into 2 10 means 12. This is in echelon form. Here number of zeros before non-zero entry be less than number of zeros before non-zero entry of third row. Number of non-zero rows be 3. Number of non-zero rows be 3. Therefore rank of A equal to 3. Now we solve the next problem. Next problem is, let A be a 4 by 4 matrix. Frame A in echelon form and find its rank. A, matrix A may be changed by elementary transformation. Here we have 1, here 2. We may interchange these rows R1 and R2. Interchange. Here we write the second row here 1 minus 2 minus 4. Then first row 2 3 minus 1 minus 1. 3 1 3 minus 2. Third row 6 3 0 minus 7. Fourth row. Now we make here 0, here 0, here 0. So for this R2, in the place of R2 we use the elementary transformation R2 minus 2R1. Here we make 0. R3, in place of R3 minus 3R1. Here we make 0. R4, in place of R4 we write R4 minus 6R1, and we get the matrix. Here we need to make 1. So 5 minus 4 1. So we use the elementary transformation in place of R2 minus R3, and we get here 1 minus 1 minus 2 minus 4 0 1. 5 minus 4 1. 3 minus 9 is minus 6. 7 minus 10 minus 3 0 4 9 10 0 9 12 17. Here we make 0. So in place of R3 we write R3 minus 4R2. Here we make 0. R4. In place of R4, R4 minus 9R2. And we get the matrix. We divide third row by 3. We divide third row by 11 and fourth row by 22. Third row R3 in place of R3 1 by 11 R3 R4 1 by 22 R4 and we get matrix 1 minus 1 minus 2 minus 4 0 1 minus 6 minus 3 0 0 here 3 here 2 dividing by 11 here 0 0 here dividing by 22 3 here 2 to make here 0 here 3 minus 3 3 minus 3 equal to 0. So we use elementary transformation R4 in place of R4 R4 minus R3. We write first row same 1 minus 1 minus 2 minus 4. Second row same 0 1 minus 6 minus 3. Third row same 0 0 3 2. Here fourth row minus third row we write 0 0 here 3 minus 3 0 here 2 minus 2 0. So number of non-zero rows equal to 3. Therefore rank of A equal to 3. And this is the echelon form of the matrix A. This is the echelon form of matrix A. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.